I would like to do a video about this engine and about its problems and how to fix them. So this engine basically shares the design of a 4-stroke gasoline engine. The only difference is that the fuel injection system here. So this is actually based on Finhanson's 4-cycle diesel engine design, but this one comes in many differences. So the first thing we could notice is that there's only one oiler here, which actually I filled it up with the cylinder oil. You can actually see that this oiler, maybe you are not seeing it clearly, but there's a small hole drilled through here. The oiler just drips oil onto the running piston and the liner surface. There's no forced lubrication, so you need some kind of a oiler to oil all of the moving parts. And since this is a 4-cycle engine here, we have the intake and exhaust valve. Here is a decompression, but sometimes if you directly just hold this one and lift it up to push down this valve, exhaust valve, this set screw here will slip on this shaft. So to avoid that, I normally just spin the flywheel and wait for the cam to push down this exhaust valve, and then use this to hold the valve open. The two cams seems to perform good, and there's very minor scratch on the cam. I cannot actually feel it with my nail. I can't feel any roughness here. So that you might be curious, why this drop of lubrication oil has kind of a metal debris inside. Yeah, I was curious about that at first as well, but later I found that most of this metal debris is not coming from these rollers, but actually it's from the valve steams, the contact from these valve clearance adjust screw. These screws are iron or steel, I believe, but these valve steams, at least on this engine, it's brass. And I have seen that since this is based on a 4-cycle gasoline engine, some of the valve steams are kind of alloy, or maybe that's aluminium, but I'm not sure if it's steel or some, but those are not brass. So anyway, I have already seen some scratched marks on these two valve steams, but that doesn't matter because you can always eliminate any clearance, I mean the increased clearance, by adjusting these two screws. So another contribution for this brass debris inside the lube oil is actually from the contact of the rocker arm and the central shaft. The way I found that is because actually during today's operation, I feel so much blowback from the intake, which is located here. You can actually see some carbon deposits there. Yesterday, there's nothing there. There's just clean oil, which is just lube oil dropped from the cylinder head, just clean, but today it's all black. So I was curious, why is such a difference? And then I noticed that this central shaft actually has you can see that, sorry for the focus, but yeah, you can actually see that the whole valve unit is actually a little bit loose inside this green holder here. Before, they only have one set screw inside this green holder. I just call it holder here, but anyway, the purpose is just to hold this shaft here. So that previously it's only one small set screw inside, but it's not that screw got loose, but it's the friction between the shaft, not the friction, but the tremendous amount of force between the shaft and this aluminum material holder. It actually rounded the inner hole of this holder. So there is a clearance between the shaft and the central hole here, so that this whole unit, you can see it's actually moving like that. Actually, I have fixed it, and now the clearance, anyway, it's closer to the factory setting, but before I fix it, actually this kind of a small clearance changes the valve timing a lot, because you can imagine that since these two valves on such a small engine never have an overlap, so one valve, when it's open, another valve, normally it won't have any force acting on it. So if this central bore and this shaft have a large clearance, actually the movement will be very great, because this end will be contact with that point inside the bore, and this shaft here will contact with this left end of this bore here. Anyway, how I fix it is that I put a very thin copper paper. I mean, it's just a very thin layer of copper used for shielding of high frequency electronic circuit. I cut a little bit of that copper tape, or anything you call it, copper film, just like just the same. I mean, it's a rectangular shape, definitely, and the short side of the rectangular copper film is the same as this shaft diameter, and the length is just enough to cover from left to right here, cover the inner bore. I mean, the same as this diameter, not because any special requirement, but anything larger than that, actually I tried, I cannot put the copper film inside while still insert this shaft. So just use a little bit kind of material inside to support this loose shaft, and kill that clearance will be fine. And also, before I take it apart, there are two C-shaped clips, such as this one, and there's another one here, but actually I do not mount it here, because I feel like it's extremely hard to take it off, and I feel like even I repaired this clearance here, it will not last very long, maybe 2 to 3 hours. So I will not mount that clip here, and it seems to work fine actually. The last thing is that I put another set screw here, so there are actually two set screws help to secure each other. So that's enough about the valve system, and yeah, I think the cams didn't have any problem, and also I believe that the exhaust valve, sometimes it leaks a little bit, but you do not actually need to take it off to grind it or lap it. Actually, it's just because the carbon deposit holding the valve sealing surface slightly open there. You can just roll the engine a few turns, actually, or you just start the engine to run it. The way I notice there is a leakage is that I have the habit that after each run I will check the compression. So I hear a very little bit of hissing sound, but the engine definitely will start even the valve is leaking. That's a very slight leaking, just very rare. Also, these two gears never have a problem for me, and definitely the most important thing on a diesel engine is its fuel injection system. So this fuel injection system is based on Finn Hansen's design as well. It's basically the same principle. So for those who have not watched Finn Hansen's video, I will briefly explain how this thing works. So this is just our flyball governor. I will talk about the modification to it later. So this is a flyball. It will just like this, open, just like this, move like because of the centrifugal force, and you can see there is such a shape so that when it moves out, the whole out block will be lifted up, and there is a coupler here. The coupler here to transmit this kind of a linear movement into such a wedge here, and you can see that this is a fuel injection pump. And this shaped wedge, it has kind of a ununiform thickness. So when this thing is pulled out by the movement of the flyball governor because of the speed rising, actually the effective stroke will be less, right? Because actually the clearance between the cam follower, the roller, which is hidden here, we will take a look at it later. The distance between that cam follower and the cam becomes enlarged. But you also need to notice that such a movement actually decreases the fuel injection timing as well. So when the speed drops, this thing inserts again, and the effective stroke of the plunger increases. Also, the fuel injection timing is actually how can I say it? Increased anyway, like more increased. So this is a fuel injection cam. It's a very interesting shape, I would say, this brass part here. So it's actually a very acute slope, but this slope definitely is not a constant speed or any special cam, but I just feel like they did it such way anyway. So yeah, anyway, it works. So this is a prime handle. You can see that silver part. When I push it down here, this pump will be pushed down, and it's for priming, bleeding the air out of the high pressure system. So from the injection pump here, we have the fuel injection high pressure pipe all the way to the fuel injector here. This injector is the same principle. I mean the principle, not the construction. The same principle of those pre-chamber diesel engines. It's a single spindle, spindle and a single spindle and a central injection hole. So the spindle is pressurized by a spring. And by this lever, this spring is a expansion spring, and the spindle, you can see this tiny shaft is the shaft of the spindle. So when the high pressure fuel reaches the spindle pressure surface, the spindle just moves slightly outward against this spring force, and the fuel is injected into the cylinder. So these two holes are kind of holes drilled through the manufacturing process, but they are sealed by some set screws. You can see this diesel fuel leakage. It always will be there from this screw here, because this screw commutes with the high pressure channel, while this screw here only commutes with the return fuel line. It's just atmospheric pressure. So this screw never leaks, but during the operation you will see this screw has some oil buildup here. I would say such a pour of diesel fuel only requires maybe 30 to 40 seconds during the operation. Although I have tightened this screw many times. Anyway, that's acceptable because you always have too much fuel injected. Yeah, that's definitely negligible. And the thing I would like to say is that since we are actually having very fine machined parts here, the set screw is seems to work fine, but if you don't tighten it really hard, this cam can actually move on this timing shaft, which will give you a no starting problem, and you will be wondering why. Sometimes it just suddenly slips there and you don't know when it will happen. So this screw here is a maximum fuel setting screw. It's just a stop screw just holding to this brass part here. Because we have talked about it when going inside, it's a maximum fuel, and yeah. So that let's just take a look at the cam follower. But the cam follower seems to work okay. It never have any problem for me. It's very hard to see in this direction, but yeah. Yeah, I will point it out for you. So this thing here is actually the base, the bottom part of the cam follower. There's a roller above it, but we cannot see it now. Anyway, let's move to the governor. Clearly, I have done some modification to the governor, because actually the originally designed governor seems these two flyballs are too lightweight. Also previously there was a spring inside it, but that spring is definitely too strong. So I moved it away, and yeah, I added two mass to the flyball, just some nut I found, and just use some adhesives to fix them temporarily, and a small spring here, a speed control lever. So yeah. So the water pump is the same as the gasoline engine, and never been changed seems, and it works fine, but just you need to give it some oil here, and also on the eccentric drive here there's an oiler hole here and here, and don't forget to oil this bush here. So let's move on to the piston and connecting rod assembly. So before, this engine has a compression ratio of 20:1, That will lead to roughly 170 kilograms of force on such a 22 millimeter diameter piston. And when the ignition happens, the pressure built up so much that it actually bended 3 of my rods. Sorry, the flashlight just went off due to the high temperature of the phone, but I will keep on shooting the video. This rod has been chewed, but it's still, you can see it's bended. So this is the original piston. It doesn't have any combustion chamber as what a diesel engine will require, but after I bended 3 rods, the first one actually bended because of the starting fluid, but the second and third rod actually they bended by the high compression ratio, I believe. Also because of the piston ring, which we will talk later. So after that, I chewed the third piston rod because it's the least bended. It's actually this rod here. It's chewed. And I use the screw slab to machine a small bowl-shaped area inside the piston. So now the compression ratio is down to 16:1. But the engine still starts very good. Yeah, also the piston ring. This kind of a shape, the design of this shape, you can see it. Bad focus. Anyway, you can see there's kind of a step on the side, and there's definitely some area in between the layer, inner and outer diameters. So originally the ring is mounted on the first groove like this, like the hollow shape facing toward the combustion chamber. I believe such geometry is to use the high pressure to help expand this outer diameter and for achieving a better sealing between the cylinder liner and the piston. But actually such a geometry, when I tried it on this engine, it immediately bended the rod even if the compression ratio is down to 16:1. So after that, I was thinking how I will be able to start this engine anymore. I don't want to deal with so much bended rods. So I mounted it like this. So now you can see that it actually acts kind of a safety valve, but it starts okay. But I'm not sure if this is the reason that the ring on this engine never lasts over 1.5 to 2 hours. Maybe because the high temperature combustion gas gets into this kind of a stepped area. Also because of the safety valve function, some high temperature gas during the knocking will go past this ring and to heat it, and also carbon deposits might get into there. So this ring never lasts more than 2 hours, and this is actually a defective ring that I just took off. But it seems recovered a little bit, because when I just took it off, the side is just flush. But now it's recovered some kind of a step there. I will try using it when this ring got dead later and tell you the result in the comment. But anyway, so the next thing, okay, better now. The next thing we will talk about is the piston pain, which is here. It's very terrible that the pin of this piston actually slide to this side and make some marks on the piston, skirt, and also the inner surface of the liner. These two marks, I can feel it with my nail, but just a very slight feeling. And also it holds the pressure still very good. It really holds the pressure very good, which is very surprising to me. But you can see that how they fix the position of the pin is actually just some slight deformation of the aluminum. There are some marks, you can see it, right? Those are for holding the pins in place or just stop them to move to the surface of the piston. You can see those marks. But I'm not sure if this is the original design, because this is previously a gas engine. So that engine might not have tremendous amount of force, but for diesel engine you might want some other kind of ways to hold the pin in space. But anyway, I have ordered a new liner and a new piston assembly, so I won't worry about this scratched liner anymore. But now it starts okay and never leaks any gas. So I think I have finished all of the needed thing to know and how to repair them. But there are two important but very strange phenomenon, which is that we go back to this valve shaft. When the shaft warms a bit, this whole unit will swing and leading to a late or retarded valve timing. It's not only retarded, but the how can I say it? Like the time duration the valve hold open will be decreased as well. So that will give you insufficient scavenging or the gas exchange maybe in the 4th cycle. So anyway, that will lead to incomplete combustion and will lead to excessive fuel accumulated in the chamber. That will result in the engine knocking. I will put a video of how this engine knocking sounds like at the end of this video. But that is because that knocking is not due to this valve timing, it's due to this set screw on the injector shoot off because of the vibration and the injection valve hold open. Too much fuel gets into the chamber and lead to a knocking. I will put that at the end of this video. So when you have noticed the engine knocking, and no matter how you adjust the fuel and the timing, you cannot solve that problem. Maybe it's the valve get loose. Sorry, the shaft got loose. That kind of a knocking is like when you manually decrease the fuel index. You pull this out manually. The engine still knocks until it stops. Normally, the engine only knocks when you give it too much fuel, and when you decrease the fuel, the speed goes down. And when you just hold it at a reduced speed, the engine should still run, right? But when that kind of a knocking, due to the insufficient scavenging happens, no matter how you manipulate with this fuel setting, the engine either knocks or stops. So that is a way to tell which kind of a knocking, what is the cause of the knocking in such a diesel engine. So that's all about today's video. And in the future, I will try to reduce the idle speed of such an engine a little bit more. In my latest video, this engine has run at the idle speed, I would say like 360 to 420 revolutions per minute. But I hope this engine can reach 250 or even lower. But I know that due to the weight of the flywheel, it might be hard. But I will try to retune it and maybe do a little bit of refinement to it. So one last thing I just remembered. For starting the engine, although it can be started from cold, but that will, take a lot of time and revolutions. I do not want that because that will lead to too much excessive fuel accumulated in the cylinder, and then they will ignite and lead to engine knocking and the sudden rise in speed. Although the governor can drop the speed down, but I do not want to experience that kind of acute rising speed and knocking. So always I use a blowtorch and to adjust the flame into just a soft flame, not a torch flame. You heat this part of the cylinder jacket. Normally it takes like 30 to 40 seconds until I feel like this part, the temperature of it reaches maybe 60 to 70 degrees Celsius, and the engine can be started very easily with a very low fuel setting. You can see that this kind of a fuel setting is actually very low, but this is enough for starting, and even still lead to some kind of a knocking. So that's all about today's video. Hope you will find it useful. Thanks very much.